Okay, guys, welcome to Unit 5. Today's lesson, we're going to be talking about logarithms and logarithmic functions. We call them logs for short. So what a logarithmic function is, it has to do with exponents. So keep that in mind throughout the unit. So we know that 2 to the third power, 2 to the power of 3 is called a power. The parts of this power are to the right. So the 2 is called the base, the 3 is called the exponent, and then the 8 is called the product. So the whole thing, 2 to the third power, is called the power itself. Now, what we're going to introduce here is an exponential equation. It has a variable as its exponent. So when we say 2 to the power of x equals 8, that's an exponential equation. And we're trying to think, like, what is x? We know that x must be 3, because 2 to the power of 3 is 8. 2 times 2 times 2 is 8. Now, having a variable as an exponent can be difficult to solve. So in this early 17th century, that would be the 1600s, John Napier introduced logarithms to simplify calculations. Now remember, this was way before the time of calculators, and calculators weren't just magically created in new algorithms. Somebody had to know how to do algorithms to program them into the calculators. So a logarithm is the exponent of the power. The symbol for logarithm, of course, is log for short. So log, how we would read this with the 2 and the 8 here at the top, we would read this as the log base 2 of 8. I'll repeat that. The log base 2 of 8. So what that means, again, is 2 to the power of what is 8? Obviously, where that question mark would be the x. So as you can see, that's how a logarithm can relate to an exponent. So we can find certain logarithms without a calculator. So let's use the definition of logs to find some easy log values. So we're going to use this property here, this definition, that shows, so what we do is we call this base A. So log base A of x is, again, notice log base A is the big base A when it has to do with the power. And then the log base A of x, that is equal to x here if we turned it into an exponential equation. And then the exponent has to do with the y over here. I understand you guys are probably a little confused. Just let's go through and hit up some examples now, and hopefully it'll make more sense. So in example 1, we're going to find each of the following logs using mental math. So log base 10 of 10,000. That, we got to think, 10 to the power of what? 10 to the power of what is 10,000? 10 to the power of what is 10,000? Well, there's 4 zeros. So 10 to the power of 4 is, there's 4 zeros in 10,000, so 10 to the power of 4 is 10,000. So I would say my answer for this problem is 4. Let me back up here. So I would say this is equal to 4. So log base 10 of 10,000 is 4. So let's try another one. Log base 2 of 64. What is that? We have to think. 2 to the what power is 64? You could use your fingers on the side here. 2 times 2, I'm actually using my hand. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So I have 6 fingers up right now, so that would be 6. 2 to the power of 6 is 64. So the log base 2 of 64 is 6. So again, guys, we're thinking of exponents. Our solutions to the logs are actually the exponents. So letter C, log base 3 of 81. What would that be? So again, you could use your fingers. or a calculator. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. I have 4 fingers up, so that would be 4. Letter D, log base 9 of 1. Well, that's a tricky problem here. 9 to the power of what equals 1? What would that be? Well, it can't be 1 because 9 to the first power is 1. It couldn't be 2 because 9 to the second power is 81. What about 0? It is 0. Remember that anything to the power of 0 equals 1. Okay, letter E, log base 14 of 14. So 14 to the power of what is 14? Well, that's easy. It's 1. 14 to the power of 1 is 14. Very easy here. Again, we're thinking in terms of exponents. And letter F. Little tricky here. It's saying log base 4 of 4 to the power of 9. So 4, the way I'd like to rewrite it, so I go 4 to the power of what equals 4 to the power of 9? Well, that would have to be 9. They would have to match. Okay, on the next page, we're going to learn how to convert between exponential and log equations. So let's now use the definition of logs to convert back and forth from exponential to logarithmic equations. And you can see this property here on the box is what we've been discussing already. So we're now, okay, so example 2 says, convert each of the following to a logarithmic equation. So let's go, okay, it's log, and then what's the little base? The little base for the log is the big base for the power. So log base 2. As you can see, that would be, if you look up here, that would be where the A's are. We're just looking at this box as we go through this until we commit it to memory. And then, so it's log base 2 of 128, and then it equals the exponent in the power, which is x. Now, we aren't solving here, but if we were to solve, it would actually be 7. 2 to the power of 7 is 128. Okay, let's try letter B. So log, it would have a base 10, little base 10, because the power's base is 10. And then, so log base 10 of 0.0001 equals, and then it would be equal to -4. It's equal to the exponent, okay? Just like here, the exponent y and y, that's the -4 we're talking about. Okay, so, and by the way, 10 to the power of -4 is actually 0.0001. If you remember that, that has to do with scientific notation. All right, letter E. Don't worry so much about the E. What E is, actually, let's just convert it. Log base E of 75 equals T. We'll learn more about base E later on. Maybe not today, maybe another day. All right, letter D. So log base M of 2 equals 2/3. Pause and try letter E on your own. Okay, so this would be log base 6 of 216 equals 3. So the exponent, that 3, always goes standalone by itself, equals 3. Makes sense. What this log is telling somebody is, if I were to ask you guys, hey, what's the log base 6 of 216? You would say it's 3, because 6 times 6 times 6 is 216. Letter F's a little, not tricky to write, but it's just tricky to comprehend. So that would be log base 81 of 3 equals 1/4. All right, so that was just converting an exponential equation to a logarithmic equation. So now in example 3, we're going to do the reverse of that. We are going to we're going to take these logarithmic equations and we're going to convert them to an exponential equation. So again, you can always look back up here to this box. That's what I referred to when I was learning this. So in A, we have log base 2 of 256 equals 8. So the little base 2 is, the little base is 2, so that becomes, for my power, big base 2. My number that's alone on the one side, that 8, that will become my exponent. And then obviously it would have to be equal to 256. And it makes sense. This statement is actually true. 2 to the power of 8 is 256. All right, next up, letter B. Log base B of r equals 9. So little base for the log becomes big base for the power. The equals 9, the standalone 9 becomes my exponent of the power. And then equals r. Letter C. The little base here is v, so that becomes my power's base v. The number or variable that's by itself becomes the exponent, so v to the power of y equals n. Letter D, log base e of e equals 1. So that little e becomes my big base e for my power. My standalone 1 is my exponent, and then equals that bigger e. And that makes sense. E to the power of 1 is e. Anything to the power of 1 is itself. Okay, letter E, log base b of v to the 4th power equals y. So just use your rules, don't get intimidated. So little base b of the log becomes base b of the power. The standalone, the y by itself, is always the exponent. And then equals what's left, v to the power of 4. Letter F, little base e becomes base of the power. What here would be the exponent? What would be the exponent of e? It would be x, that standalone x. And then equals whatever's left is that s to the 7th. We don't know what these values are. We're just, in E and F. In C, in B, C, E, and F, these are just kind of made up problems. Okay, so unfortunately, I don't have calculators in the class. I'm teaching this, obviously remote, but finding logarithms on a calculator, before calculators became so widely available, base 10 logarithms are called common logs. Anything with a base 10 is called a common logarithm. These common logs were used extensively to simplify complicated calculations. In fact, that is why logarithms were invented, to think of a lot of things with that base 10. 10 to the power of what? So the abbreviation log with no base written is used to represent common logs or base 10 logs. So if you ever see this, like log of x, that really means log base 10 of x. It's like one of those things in math, like you don't put a 1 as a coefficient, you don't put a 1 as an exponent, you don't put a 1 as a denominator, because they occur so commonly and so often that you don't need to write them. It's like it's understood what it is. So whenever you have log of 10, that really means log base 10. Log of x means log base 10 of x. So again, these are called common logs. Please remember that term, common log. So calculators, they do common logs. If you locate a calculator, say on your iPad, or if you have a scientific calculator, like on the side, I'm actually working with a TI-30. On my calculator, there is a log button, and then it opens up parentheses. So when I hit the log button, it opens parentheses, and I literally just put the digits in, and then I hit enter, and then I'm going to round. More decimal places, the better. You definitely don't want to round to a whole number here. Let's get at least like 2, 3, maybe 4 decimal places. The more, the better. So what does this mean? What does this 5.8101 mean? What it actually means is 10, that's right, because 10 to the power of 5.8101 gets you 645,778. So that's where this stuff makes sense. We're trying to figure out what the exponent is, and sometimes these exponents are not whole numbers. So using a calculator here, this would be log of 0.000239. So again, it's not showing the 10, but remember this is log base 10. So I go to my calculator, I hit log, and then I put in 0.000239, and it's going to give me a negative. So negative 3.6216. It is a negative because remember, a negative, this negative 3.6 is an exponent, and remember, scientific notation says that when we have anything to a negative exponent, it creates a very tiny decimal. Letter C, log of negative 3. So that's log base 10 of negative 3. Don't worry about putting the 10 in. Again, ignore the ignore the 10, sorry. Just put log of negative 3 in your calculator. And you will notice it'll give you, my calculator says domain error. What does that mean? It doesn't exist. It doesn't exist. There's a rule in math. You are not mathematically able to get the log of a negative number. Okay, guys, that was about 20 minutes. I'm going to stop the video there. And the next time we'll continue on for part 2 with natural logs.